What if humanity's end doesn't come from Earth at all, but from the stars? We live with constant threats. Asteroids tumbling through the void. Supervolcanoes waiting beneath our feet. Climate collapse unfolding in slow motion. Even nuclear war, our own hand poised above the trigger. These dangers haunt us because we can see them. We can imagine them. We can, at least in theory, prepare for them. But above us, hidden in the silence of space, lurks a threat far greater. A threat that cares nothing for our borders, our technology, or our will to survive. A threat so sudden, so unstoppable, that it could erase our species overnight, without a moment's warning. It's called a gamma-ray burst. What exactly is a gamma-ray burst? Gamma-ray bursts, GRBs, are the universe's most powerful explosions, storms of energy so intense that they dwarf supernovae and rival the birth of black holes. They are born in violence, unleashed when massive stars collapse or when two neutron stars crash together in cataclysmic collisions. In that instant, jets of radiation are hurled into the cosmos, beams of gamma rays traveling at nearly the speed of light. For a few seconds, they outshine entire galaxies. In the blink of an eye, a GRB can release more energy than our sun will in 10 billion years. But here is the question that haunts astronomers: what if Earth ever stood in their path? How far away would it need to be to destroy us? The universe is vast, and most GRBs occur billions of light years away. From that distance, they are fireworks in the sky, dazzling but harmless. But distance is survival. Too close, and the story changes. Astronomers calculate that a GRB within 6,000 light years, if aimed directly at Earth, could be catastrophic. That may sound far. But in cosmic terms, it is uncomfortably close, a neighborhood we share with thousands of stars. The blast would not incinerate us instantly. It would do something more insidious. Its radiation would rip through the upper atmosphere, shredding the ozone layer that shields us from the sun. Within days, ultraviolet radiation would pour down unfiltered. Crops would wither. Oceans would lose the plankton at the base of their food chains. Skin cancers would spike. Eyes would go blind. Ecosystems would collapse. Civilization would unravel not in centuries, not even in decades, but in months. Would we see it coming? This is the most terrifying part, probably not. Gamma-ray bursts are sudden, unpredictable, and highly directional. Their beams are like cosmic sniper fire, narrow and precise. Unless a star's death throes were already being watched at the exact right moment, Earth's first sign of danger would be the burst itself. And because GRBs travel at light speed, the instant we saw it would also be the instant we were struck. No warning. No preparation. One night, we might fall asleep beneath the stars, and never wake again. Could a GRB already have rewritten Earth's history? The fossil record tells a story of repeated destruction. Mass extinctions where life was nearly erased, only to begin again. Some of these events are understood: asteroids, volcanic winters. Others remain mysteries. One such mystery is the Ordovician extinction, 450 million years ago, when 85% of marine species died. Some scientists suggest it was caused not by rock or magma, but by radiation. A nearby gamma-ray burst, striking Earth with invisible fire, stripping ozone, collapsing ecosystems in days. If true, then life on Earth has already felt the wrath of the stars once before. And it could happen again. Are there stars near us capable of firing? Astronomers watch the skies with unease. There are candidates. One is WR-104, a Wolf-Rayet star about 8,000 light-years away. Wolf-Rayet stars are massive, unstable, their cores stripped bare, destined for collapse. When they die, they may unleash gamma-ray bursts. And WR-104 appears to be aligned almost directly with Earth. If it explodes within our lifetime, its jet could be aimed at us. Or we may be spared by degrees, survivors of a cosmic roulette. For in the game of gamma-ray bursts, survival is a matter of angles. A difference of a few degrees is the difference between thriving civilizations and sudden extinction. What would happen in the first hours after impact? The atmosphere would convulse with radiation. Within hours, the ozone layer would collapse. The sun, once life-giving, would become a killer, its ultraviolet light flooding through. Crops would blacken. Forests would wither. The oceans, birthplace of life itself, would lose their plankton. With them, the chain of life would unravel. Fish would starve. Birds would vanish. Famine would spread from the sea to the land. Even those who survived the initial radiation would face a poisoned earth. Skies dimmed by nitrogen oxides. Air tasting of metal. Food chains crumbling into silence. Humanity would not vanish instantly. It would stagger, clawing for survival, before collapsing into extinction. Could humanity survive underground? If we had warning, even days, we might prepare. We might burrow into the earth, shelter in bunkers, shield our cities with layers of rock and water. But the truth is cruel, a GRB would not give us warning. Only those already underground, in mines, submarines, or shelters, might survive the first wave. Civilization above would collapse overnight, leaving only fragments of humanity in the dark. But even then, survival would be temporary. The poisoned skies above would not heal quickly. The sun's radiation would remain deadly for years, perhaps centuries. What future could grow in such a world? Are gamma-ray bursts also messages from the universe? Why do such explosions exist? Why does the cosmos wield such terrible weapons? Some scientists wonder if they are more than accidents of physics. Perhaps they are part of cosmic evolution. A way the universe prunes the tree of life, resetting planets, forcing adaptation. By fire, by radiation, life is tested. Weak civilizations are burned away. Strong ones, those who spread, diversify, endure, survive. Perhaps GRBs are not villains, but gardeners. Terrifying, merciless gardeners, cutting life down to give new life space to grow. If so, then humanity's survival may not be guaranteed. We may be only one flash away from erasure. Could technology ever protect us? Could we build defenses against a cosmic sniper shot? In theory, perhaps. A civilization far beyond ours might construct planetary shields, redirect radiation with magnetic fields, or even cloak entire worlds. But for us, such dreams remain distant. Today, we cannot stop a GRB. We cannot deflect it. We cannot hide from it. The only true defense is distance, to scatter ourselves beyond Earth, beyond the solar system, so no single burst could ever erase us all. Colonies on Mars, habitats around other stars, seeds of humanity planted in many soils. Survival by dispersal. Until then, we are trapped. One fragile world, under a sky filled with silent crosshairs. What would happen to our legacy if we vanished overnight? If humanity were ended by a gamma-ray burst, what would remain of us? Our cities would crumble. Our satellites would fall. Our monuments would erode. Within centuries, the Earth would be silent, reclaimed by time. Perhaps the only trace of us would be the golden records aboard the Voyager probes, drifting endlessly through the void. A child's drawing, a mother's laugh, a song etched into metal, whispers of a species erased by the very cosmos it sought to explore. Would anyone find them? Or would our story end as nothing more than dust in the wake of a cosmic flash? Should we fear gamma-ray bursts, or accept them? It is easy to see them as villains, threats lurking in the dark. But perhaps we should see them as part of the balance of the universe. They destroy, yes, but they also create. In their fury, they forge the heavy elements that make planets, oceans, and life itself. Perhaps without gamma-ray bursts, Earth would never have formed. And if one ends us, then perhaps it is only completing the cycle it began. The question is not whether a GRB could end us overnight. The answer is yes. It could. And we would never see it coming. The real question is what we do with the time we have. And so the question remains: could a gamma-ray burst end humanity overnight? The answer is yes. But maybe that is the true lesson of the cosmos, that life is fragile, existence is temporary, and every moment we have is borrowed time beneath a sky filled with silent storms.